Okay, number 43, passing through the points -3, -4, and 3, 0. Alright, so you can plot those 2 points, connect them with a straight line, and that line has an equation y equals 2/3 x minus 2. You can use the 2-point equation to get that, but here's the answer in your book. Just plot those 2 points and connect them with a straight line. Number 45. For the following exercises, sketch the graph of each equation. Alright, so we have g of x equals -3x plus 2. So this is written in slope-intercept form, so that tells us that the y-intercept is 2 and the slope is -3. So we can use that information to draw this. Alright, so let's see, we've got a y-intercept at 2, 1, 2, right there. Plot that point. Slope of -3. That can be written as -3 over +1, or +3 over -1. Okay. Either one is going to work pretty well for this graph. Because I've got room going either way. Well, it's a little bit less going up. If I use this expression here, +3 over -1, that means a rise of +3 means you go up 3 from the point here. 1, 2, 3. And to the left, 1. That's a run of -1 to the left. Alright, so this one is maybe better because we have more room going this way. So a rise of -3 means you go down 3. 1, 2, 3. And a run of +1 means you go to the right 1. So there's your point, your other point on the line, and you get a straight edge. Don't follow my example. Get a straight edge and connect the dots like that. After many years of doing this, I can do it pretty well freehand, but it's still not perfectly straight, of course, but you get the idea. Oh, and by the way, here's the answer in your book. Number 47. K of x equals 2/3 x minus 3. So here the y-intercept is -3. Alright, -3, and the slope is 2/3. So slope m is 2/3, can also be written as -2 over -3, because that's equal to +2/3. Negative divided by negative is positive. So let's draw a quick set of axes. And let's see, we've got a y-intercept at -3, 1, 2, 3, right there. Plot a point. And we have a slope. Let's see, which one should we use? This one? That means a rise of -2 means you would go down 2, and then a run of -3 means you go to the left 3. Well, I don't know, I'm kind of running out of space. Let's go use this one. Rise of +2 means you go up 2, 1, 2, and a run of +3 means you go to the right 3. Let me draw those in. So right there. And then connect the dots. And there you have it. All right. Here's the nice, neat answer in your book, which looks kind of like my answer. All right. You can use your imagination and make it look exactly alike. Number 49, we have P of t is equal to -2 plus 3t. Alright, so let's draw in a set of axes. This time we have a t-axis. That's your independent variable, a t. Usually stands for time. And you could call that a y-axis if you let y equal p of t. Or just call it p or p of t. Alright? I'll just call it p. Maybe that's population, who knows? Population with respect to time. Okay, so p or p of t, or you can call that y, and as long as you understand that y equals p of t. Alright, so what do we have here? Okay, now even though it's not quite in slope-intercept form, it's you can easily see what the slope is. Y equals mx plus b, right? Well, the x is the variable. In this case, we're using t as the variable, the independent variable. And the number next to it is the slope. That would be 3. So slope m equals 3 over 1, or -3 over -1. And the y-intercept is -2. So let me plot that right now. Right there. So let's use this one, since you're going to go up and to the right. This one you're going to go down and to the left. Alright, I'm kind of running out of room here the way I drew this, so I'd rather go up. So from here you go up 3, 1, 2, 3, and to the right 1. So again, start here, up 3, 1 unit, 2 units, 3 units, and then to the right 1 unit. There's your second point. And connect the dots. And there you go. Here's the official graph right there. As you can see, they labeled it X and Y because they're in the same habit that most of us are in, right? Call it X and Y. But actually it should be T and P or P of T. Okay, number 51, we have x equals -2. So anytime you have an equation, x equals some constant, you know you have a vertical line, alright? And the x, or rather the points that are on this line always have coordinates x equals -2 and then whatever y is, alright? Y can be any real number. So let's go, right there is -2 on the x-axis, and you just draw your line through there vertically like that. Alright, so any point on this line has coordinates -2 and y, whatever y is. Alright. Number 53. Q of x equals 3. Okay, so instead of Q of x, you can write y equals 3. Let y equal Q of x. So it's pretty simple. Anytime you have y equals some constant, you know that the line will be horizontal. So you could write either y for the y-axis, or you could write q or q of x if you wish. Alright, now the coordinates for any point on this line will have the form x and 3, where y equals 3. Y will always equal 3 for any point on this line. And x will be whatever it is. It can be any real number. Okay, so you find y equals 3 on the y-axis. 1, 2, 3. Draw a horizontal line through that. And there you go. That's it. Y equals 3. So any point on that line has the coordinates x and 3. And there's your book's answer, which is what we expected. Number 55. We have x over 3 minus y over 4 equals 1. Alright, so what we want to do is isolate the y here. Okay, you want to write it in the form y equals mx plus b. Alright, the slope-intercept form. So first of all, we move the negative y over 4 to the other side and move the 1 to the left side. So you've got x over 3 minus 1 equals y over 4. Alright. And now, you don't want to multiply both sides by the common denominator of these two, because you're just making more work for yourself. Alright. What I want is the y to be by itself. So I just multiply both sides by 4. That'll clear that 4 out of there. Alright. So I've got 4 times x over 3 minus 4 times 1 equals 4 times y over 4. Multiply both sides by 4, so that'll cancel the 4's out. That leaves you just with y. And so we've got, let me just put the y first on the left side. Y equals, that's 4 over 1 times x over 3 is 4/3 x. Minus 4 times 1 is minus 4. So 4/3 x minus 4. Alright, so to draw this, we have, I'm not going to bother with a lot of the details here, but minus 4 is the y-intercept. 1, 2, 3, 4. Mark that point on the y-axis. And then we got a slope of 4/3. That could also be negative 4 over negative 3. But if you have a rise of negative 4, you have to go down 4, and that's going to run off my scale here. So I'm going to use positive 4/3 as my slope. That means a rise of 4, go up 4, 1, 2, 3, 4, and a run of 3 to the right 3. So 1, 2, 3, 4 up and to the right 3, 1, 2, 3. Right there. And then connect the dots. And there it is. And here it is in your book. Number 57, we've got 3x equals 15. Alright, what I'd like to see is x equals something, so just divide both sides by 3. 3x over 3 equals 15 over 3, and so the 3's cancel, so you get x equals 15/3, which equals 5. So x equals 5 is what we want. So it's a vertical line. One, 2, 3, 4, 5. So right there. Alright. And here is the official book answer. Number 59. If g of x is the transformation of f of x equals x after a vertical compression by 3/4, a shift right by 2, and a shift down by 4, A, write an equation for g of x. So let's let y equal f of x. Alright, so we got part A here. What we're going to do is take f of x and then transform it into g of x using the parameters they describe. So we've got y equals x. And then we've got a vertical compression by 3/4. So what I'm about to do is what I've done in the chapter dealing with transformations of functions. So if you haven't already seen what I've done in that section, you might want to take a look, because it's a little bit different from the way your book does it and the way most books do it, because I believe that it's easier to remember, although it involves a little more algebra than the way the book does it. Alright, so it's an older way of teaching this, which they don't seem to teach much anymore, so that's where I got it from. Alright, anyway, we've got a vertical compression by a factor of 3/4. So vertical suggests the y-axis, because the y-axis is the vertical axis, right? So what you do is you put 3/4 underneath the y. And then we've got equals x. And then we've got a shift to the right. So if you're thinking right shift or left shift, that's horizontal. And so think of the x-axis, because that's a horizontal axis. So y over 3/4 equals, well, let me write this down. This is your vertical compression. Alright, so that was your vertical compression, the 3/4 under the y. And now let's do the shift to the right 2 units. So you put x minus 2. Put the minus, x minus something, alright? And that's your right shift. And again, if this is confusing, you need to look at the chapter on linear transformations, where a lot of problems are done like this, and I explain them in more detail. And then we have a shift down by 4. So down suggests vertical again. So you're going to put this number next to the y. And it's going to be y minus a -4. Y minus -4, because -4 suggests a downshift. Alright, so that becomes y plus 4, minus a negative is plus, like this. So that's shift down. And again, you do the compression and stretching and shrinking. Well, the compression and stretching first, and reflecting first when you do these. And then you do the shifts, right or left. So I did that first. Alright. Okay. Now what we do is we write this as a slope-intercept equation. Alright, so I'm going to multiply. What I want to do is multiply both sides by 3/4. So I want to clear this fraction. I want to isolate the y. So multiply both sides by 3/4. Alright. So what that does is it's going to cancel the 3/4 out on the left side here. Alright. Now I need to take a little break and erase all this so I can make some room. Unless I could do it over here. Yeah, I think I've got room here. Alright, I'm going to continue it tight fit, but we'll continue it over here. So you just have y plus 4 equals, and then I'll distribute the 3/4 through. 3/4 x, and then minus 3/4 times 2. Okay, the 2 will cancel with the 4. 2 into 2 is 1, and 2 into 4 is 2. So you've got y plus 4 equals 3/4 x minus 3 over 2. And then you subtract 4 from both sides. So you got y equals 3/4 x minus 3 over 2 minus 4. 4 is the same as 8 over 2. Get a common denominator. Again, you can multiply this by 2 over 2, multiply it by 1, change that to 8 over 2. And minus 3 minus 8 is minus 11. So you've got y equals 3/4 x minus 11 over 2. Alright? So that is our slope-intercept equation, the line that we seek. Now your book's answer has, oh by the way, I should call this g of x. Just to be correct here, g of x equals 3/4 x minus 11 over 2. Alright. Now your book's answer has g of x equals 0.75 x minus 5.5. Of course that's equivalent to what I have written here. Alright. So that takes care of part A. Let's go to part B over here in this little tiny space. Part B. What is the slope of this line? Well, since it's in slope-intercept form, you can read it right off the equation. 3/4 right next to the x there. That's the slope. Or 0.75 if you want decimal. Alright? And then part C, well let me write that down, 3/4. And then part C, find the y-intercept. Well, it's easy to see right off the slope-intercept equation, negative 11/2, right at the end there. Okay, so you can also write that as negative 5.5. So the y-intercept is 0, negative 11/2, or 0, negative 5.5. Number 61. For the following exercises, write the equation of the line shown in the graph. So let me show you the graph. So you can see it's a horizontal line, so it's going to be y equals some constant. What's the constant? Y equals 3, right there. Alright? So that's the answer, y equals 3. Number 63. We have the graph here. It's a vertical line. Suggests an equation x equals some constant, and that constant would be negative 3. X equals negative 3 right there. So that's the equation. X equals negative 3. Number 65. For the following exercises, find the point of intersection of each pair of lines if it exists. If it does not exist, indicate that there is no point of intersection. So if it doesn't exist, that means you have parallel lines, essentially, all right? So let's take a look at this first set of equations on 65. Y equals 3/4 x plus 1. And we also have negative 3x plus 4y is equal to 12. So what we're going to do is substitute the first equation into the second, all right, and solve for x. See, this is already solved for y, so to speak. Y is isolated, and it equals all of this. So we can substitute all of this into the second equation where y is, and then you'll have nothing but x's to solve for. All right, so let's substitute the first equation into the second. All right, and then we'll solve for x. So negative 3x plus 4, and then times all of this, 3/4 x plus 1. So there's negative 3x plus 4y equals 12. All right. So we've got negative 3x plus, distribute that through, so you've got 4 times 3/4 x plus 4 times 1 equals 12. So we've got negative 3x. These cancel, 4 and a 4, so you've got plus 3x plus 4 equals 12. And now negative 3x plus 3x is 0. So you got, well, looky here, 4 equals 12. How about that? You didn't know that, did you? I didn't either. Wow, we've discovered a new mathematical theorem. We should submit this to all the scholars, right, and let them ruminate over this. No, actually, actually that's not true, right? If you get, this is called a contradiction, right? So you usually symbolize it like that, like a crosshatch pattern, and that's a contradiction. So obviously, right? So why did we get this? Well, it happens because these do not intersect. They don't equal each other. They don't ever equal each other. Okay, they don't intersect. So when something like that happens, you're going to come up with a contradiction. Okay? All right. So that means that there's no solution. No solution. Alright, so they don't intersect. If you came up with something that's always true, like 4 equals 4, then what you have is something that, well, basically you're going to have the same line. You're talking about the same line, but different forms of the equation. Alright, something that's always true. Okay, you'll see more of those later, get more experience with those. Now if you solve this second equation for y, you'll see that y equals 3/4 x plus 3. That's the slope-intercept form of this equation, and the slopes are the same. So they are parallel, all right? Just like we thought.